Welcome to part 2 of my video series on integrals involving powers of trigonometric functions. We'll be continuing our discussion on integrals of the form integral of sine of x to the power of m times cosine of x to the power of n dx. Remember that how we compute this integral will depend on the powers m and n. In our previous video, we looked at the first case where either the power m or the power n is an odd positive integer. In this video, we'll be looking at the case where both the powers m and n are even positive integers. Again, we'll be using some trig identities that will help us compute these integrals. We'll be using the double angle identities. The first one is sine squared of x is equal to 1/2 times 1 minus cosine of 2x. The second is cosine squared of x is 1/2 times 1 plus cosine of 2x. Another thing to remember are the following integrals. The integral of sine of a times x is negative 1 over a times cosine of a times x plus c. If you are unsure of how we got this integral, remember you can compute this using substitution. Try letting u equals a times x. Similarly, the integral of cosine of ax dx is equal to 1 over a times sine of ax plus c. Now we're ready to look at some examples. In our first example here, we're looking at the integral of cosine squared of x dx. We can think about this as integral of sine of x to the 0th power times cosine of x to the 2nd power. So we see here that both the powers of sine and cosine are even. So what we're going to do is use our trig identity to rewrite the cosine squared. That way it becomes cosine to the 1st power, which is something that we know how to integrate. So when we use our trig identity, this becomes integral of 1/2 times 1 plus cosine 2x dx. To integrate this, I'm going to distribute the 1/2. So I'm looking at the integral of 1/2 plus 1/2 cosine of 2x dx. The antiderivative of 1/2 is 1/2 x. Then we have plus 1/2 times the antiderivative of cosine 2x, which is 1/2 sine 2x, and then plus c. So that's how we compute this integral. Let's look at one more example. Let's consider the integral of sine squared of x times cosine squared of x dx. Since the power of the sine factor is even and the power of the cosine factor is even, we're going to approach this integral by using our double angle trig identities. So when we rewrite the sine squared, we can write it as 1/2 times 1 minus cosine of 2x. Then rewriting the cosine squared, this is 1/2 times 1 plus cosine of 2x dx. Combining the 1/2 factors that we have here, we get the integral of 1/4. Then multiplying out 1 minus cosine 2x times 1 plus cosine 2x, this gives us 1 minus cosine squared of 2x dx. Now when we distribute, we have integral of 1/4 minus 1/4 cosine squared of 2x dx. Now looking at this integral, we still have this term where we have cosine of an even power. So what we're going to do is use the trig identity again. That way we can reduce that power from a square down to a 1st power. So using the double angle trig identity, this becomes 1/4 minus 1/4 times 1/2 times 1 plus cosine of, and I'm going to double the angle that's within. It was 2x before, so now it becomes a 4x. And then I have dx in the end. So simplifying this, we have integral of 1/4 minus 1/8 minus 1/8 cosine 4x dx. Combining the positive 1/4 and the negative 1/8, we have the integral of 1/8 minus 1/8 cosine of 4x dx. The antiderivative for 1/8 is 1/8 x minus 1/8 times the antiderivative for cosine 4x, and that's going to give us 1/4 times sine 4x, and then plus c. So that's our final answer. So the takeaway is that if you have to find the antiderivative of an even power of sine or cosine, what you're going to do is use the double angle trig identity to help you reduce the power. That's where we'll stop for this video. In our next video, we'll look at the integral of tangents and secants.